This is a metadata video watermarking project. The primary objective of the project is to develop an advanced watermarking solution specifically designed for video streams. Our solution should be capable of embedding watermarks into the metadata of the video content. Another objective is to guarantee that a watermark can be retrieved and accurately identifies that a video stream originated from our system. Another objective is to ensure that the inclusion of watermarks does not slow down the delivery of the video content. The technology should be designed to minimize any impact on streaming or download speeds, providing a seamless and uninterrupted viewing experience for users. Our project requirements are that the system shall have the ability to embed the watermark into the metadata using techniques such as atom insertion and manipulation. The system shall detect the presence of the watermark in the metadata of video content. The system shall maintain the integrity of the watermark when the video content is stolen from the CDN and redistributed. The system shall work with a wide range of dash manifest types such as compact and non-compact. The system shall embed and validate the watermark efficiently without causing delays or performance issues. The system shall store and retrieve the UID information into a database efficiently with accuracy. The system shall be capable of handling the most common errors that may occur when running the solution. The system shall be able to accept both live video streams and video on-demand content as inputs.
Hello, my name is Manuel Castro, and we're talking today about the design, implementation, and also doing the demo for our solution. So, in our solution, we had to be able to accomplish two main goals. One goal is going to be to be able to do a watermarking inside the metadata of the video, and also we had to do that inside and streaming a real streaming service like the one that is using Warner Bros. Okay, to implement our system, we're using AWS. That's going to be Amazon Web Service, and we're using, we can see several services for AWS that are going to be like the EC2 for computation, the S3 to store information, video, and we're gonna be using like a media convert, media package, media live for doing video processing, and also we're gonna be using CloudFront to do as a CDN for content delivery, and we're gonna use in the database. So here we need to use two. We're gonna be using Dash. Dash is gonna be dynamic adaptive streaming over the internet, and we're gonna be using the Dash streaming over the VOD. That's gonna be video on demand and also in a live Dash streaming. So here you can see the workflow that's gonna work. What we're trying to do here is to try to simulate the process that the hacker follows. That means we're gonna create a signal. We're gonna embed inside the signal our watermarking, and then we're gonna simulate the process that the hacker follow. That means we're gonna retrieve the dash manifest, and then we're gonna pass the manifest. We're gonna over there download all the different video and audio fragments, and we're gonna store that inside an S3 bucket. And after that, we're gonna use a CDN to streaming that to the internet. And then our code had to be able to validate the watermarking that we embed inside. So, and we're gonna be using that one in the VOD, video on demand. That's gonna be video on demand. Gonna be a video that's gonna have a fixed size, a fixed duration, and also the live they're going to be very similar, but in that case we are producing three different endpoints. They're going to be HLS, they're going to be hyperthread live streaming, and also we're going to use a CMAF like an endpoint that is common media application format, and also the previous mention of the dash. And we also need to be able to validate the watermarking that we're inserting here. So to use it, to be able to create an access for the user to use our software, we are using Jenkins. Jenkins is a software that is used for building, testing, deploying, and also to create a secure interface where the user can access with role-based access that protect our cloud services from the access on the user. That is going to be totally isolated for AWS. That means the user is not going to have a real access to our cloud services, only the thing that we allow to the user. Jenkins is going to be connected for example, for the internet for our user, and also be connected for GitHub, also be connected to external streaming service, and then he's gonna be able to communicate with the watermarking bucket. That's gonna be our S3. He's gonna be able to the EC2 instance. He's gonna have iron role. That is what I use in AWS to assign privilege and assign roles to be able to handle the different service for AWS, and also we're going to be using the AWS CLI command line interface. They're going to be the one that's going to be creating communication between the different services, and also our database. That's going to be MongoDB in this case. That is a NoSQL database. That is not a table-based database. It's a JSON format-based database.
Okay, so this next part is in regards to our project implementation, specifically our solution for our Python script. So I will be going over the design for our main script and validation processes. So the first thing we have here is our main script. And so to start with the main script, we have an input URL, which is the dash manifest URL. We then generate a local UUID for a CPRT based implementation. So we generate the local UUID, and we also retrieve and parse the manifest. So when we retrieve and parse the manifest, we get all the necessary information out of the manifest, and it's also important to note that we're able to handle many different types of manifests, not just one specific to our AWS implementation, but it's also able to handle a wide variety and array of manifests online. Next, we have our extract video and our audio fragments. And for this part of the solution, we extract the video and audios corresponding to the representations. So we have different representations for the different video and audio quality types. We grab all of them, and then we insert the CPRT with the UUID into the specific fragment, a special fragment, a metadata fragment that we then can use to uniquely identify the stream. So for each of the representations, we insert the UUID and CPRT into that specific fragment for that representation. So we continuously do this until we've done it for all of the different representations, and then once we're finished, we then insert the record into the database. And so when we insert the record into the database, we insert a few things. We insert the UUID as well as a timestamp and a associated URL validation link that we use to then validate later on. So then we internally validate the UUID. So we do a few different things, one of which is to make sure that the UUID is in fact inside the database, and another which is to make sure that the extracted UUID is the same UUID value that we inserted, just in case there was something wrong with our process during insertion or extraction. Next, we store the fragment into the next we store the fragments and the manifest and all the content that we've downloaded and manipulated into the S3 bucket, which is then which can then be visible from a CloudFront CDN that we have pointing to it. After that, we output the results of our process, and then we stop. So that is our main script process, and like I said before, this is mainly for inserting and then internally validating and making sure that the insertion process was successful. So next we have our validation manifest process. So when it comes to our validation, it's a bit different, although it's mostly similar. So to start off, we also have a dash manifest URL as an input, and then we're also parsing and retrieving the manifest data. So the only difference here is instead of extracting all of the representation IDs and then iterating through the IDs and extracting the inits and applying the CPRT UUID to those specific quote unquote init fragments, we just get the first one, because if it's in the first one, then most likely it's going to be in the rest. So instead of extracting all of them, we only look for the first init. So once we retrieve the UUID from the init, we then check if the UUID is in fact in there, and if it's in there, then we check the value inside of we check if the value that we extracted from the init is inside of our database. And if it's inside of our database, then we've confirmed that we've been able to extract the UUID and also validate that it's in our database. So if it's not in our database records, then we can assume that, well, this does not belong to us. This stream is not a say Warner Bros. Stream, and it can belong to someone else. If it doesn't exist at all, like there's no extracted UUID, then we can assume the same thing. Or we can assume that the UUID was at some point in time stripped from the video. So either way, it's not in there and we're not able to validate. So if we're able to validate that the UUID is in the database and it does exist when we extract it, then we store the init.mp4 as well as the manifest into the S3 bucket, which we can then look into later on as a quote unquote validated URL link, right? So once that's done, that's stored in the S3, and then the CloudFront looks into the S3 and you can visualize it from there as well. And then in the end, we just output the result and then we stop the process.
Hello, my name is James, and I'm going to go over the Dash solution testing. So first of all, we went through some error handling, where we wanted to prepare for some of the most common and important errors that can occur when maybe a user inputs incorrect information. We put these in place so that if our system does encounter an error, it won't just pass it through and output any incorrect information or even corrupt the system itself. And two examples of some of these errors are unauthorized access to the database without necessary credentials and invalid URLs that do not reference a manifest file. Next is validation testing. We had to test our validation component many times by inputting many inputs that would produce both positive and negative outputs. And we had to do so until we made sure that our validation component was accurate. And another form of testing we uh, did on our Dash solution was to test the duration of time it would take to apply the UUID to the CPRT atom. And while doing this, we discovered a pattern that we initially did not understand, which was that when the uh, the system would apply the UUID to the first init file, it took a longer amount of time than it did when it applied the UUID to the following init files for the same video stream. And we realized that this was likely because Bento 4 has the capacity to cache the hierarchy, remember where the metadata is located, where Bento 4 is the tool that we use to apply UUIDs. Next, I'm going to go over the local HLS solution that both Charles and I worked on. So first, the implementation. So here you can see the process of events that occur when we run our local solution. First, we need to package a local video using FFmpeg, then generate a UUID, read from the master playlist, insert the UUID into the master playlist's header, and then we need to set paths to the local media content. And next, we can test our validation by inputting a file name. And for the file we put in, we can check if the UUID exists. If it does, it will appear, and if it does not, then it will produce no result in the terminal.
Once the watermarking process is complete, we test and validate it by running a script that requests you to enter the local file name of the playlist. Then we will search the header of the playlist for our custom header. If the custom header is present, it will print the header and UUID to the terminal. If it is not present, then the terminal will produce no result. In the process of researching and exploring video stream watermarking, we learned several insightful lessons that enrich our understanding of the important field. We discovered that different watermarking techniques come with varying levels of complexity and performance implications. A systematic research methodology involving literature reviews, practical tests, and validation proved invaluable in understanding the strengths and weaknesses of different watermarking techniques. Throughout the development process, various coding language, libraries, and frameworks were employed, leading to a notable enhancement of our coding skills. Our project's diverse scope necessitated the learning and integration of new technologies such as using Amazon Web Services, how an EC2 operates, and using Jenkins to tie it all together, which broadened the team's skills and knowledge base.
Right. So let's go back here and we can see all our code right now is stored inside our organization GitHub. And here we have three different repositories. That's going to be one for the Watermark CPRT AWS. They go to AWS and we can see the different things that we have. And we can see here we have like several inters or EC2 that are running right now. We also have our S3 bucket, and we're going to have here several videos that we are ingesting in the VOD, that means video on demand that I was explaining. And also we're going to have here the workflow for our media light. That's going to be the live channel that we're streaming on the internet. We have our CloudFront. That's going to be the CDN we're using for several scenarios right now that you can see here. Okay, so let's start. First thing at all, we're gonna copy here one of the URL for all of the videos that we are doing the VOD ingestion, right? And then we're gonna go to our Jenkins. We display Jenkins. That's gonna be the way the user can access to our application, right? And then we're gonna log in inside our inside our Jenkins pipeline, and then we can have here that we create already several pipelines that gonna allow us to communicate and do several steps and several tasks in using our code. First, for example, to communicate with the database and the directory, also display all the information stored that we have in the database, delete the directory inside the S3 buckets, and also run our script. So let's start here with the first flow that we're going to use is going to be the same process that happened with the hacker. That's going to be first, we're going to have an streaming right now we're doing with the ingestion of that BOD, we copy the signal, and then what we're going to do there, we're going to insert inside our watermarking, and then we're gonna follow the same workflow that the hacker followed. That's gonna be retrieve the information from the manifest, download all the videos and the audio fragments, and then we're gonna put that one inside the S3 bucket, and we're gonna use code from to content delivering that one over the internet. right? So that's what we're gonna do right now. First thing we have to do is we're gonna come here and we're gonna run our main script, right? And then we're gonna put here. So here we're gonna put what's gonna be our output directory. That's gonna be a Word directory that we're gonna use it temporarily to store all the information that we are downloading from our signal, and then we're gonna use the URL of the signal that we use. In that case, I'm gonna just paste the one that we are streaming from VOD, and then we're gonna click run. And then here we can see that in real time we can see how it's doing the things. It's communicating with the EC2. We are running our script, and then our script is getting all the information for the manifest, and it download all the fragment is inserting the watermarking that's gonna be the CPRT atom box with the UID embedded inside. And with that one finished, in the moment that one finished, gonna give us an output of how was the process. So here is already the pipeline already finished, and here we can see it in the logs of our pipeline that we were able to insert all the watermarking, and then we set the watermarking with this UID inside the watermarking, and also we can see the time that's going to be 26 milliseconds. That's going to be the total time take us to insert the watermarking. Here we only consider the time that real take to insert the watermarking, not the time that we are taking to download all the video fragment, because that is something we're simulating, but it's not going to be part of the real workflow that's going to be using inside Warner Bros. So here we can see that with here we generate the UID, and that was being set. Now the follow thing that we're gonna do is gonna be using we're gonna be running our validation script that's gonna take a URL of the content that we already like simulate the stealing, and we store it in the S3 bucket, and then we put it over the CDN, and then we're gonna go there, grab that URL, and then we're gonna see if we can find a watermarking with a UID inside that signal. So for that, we're gonna come back, and then we're gonna root the validation script that we have here, and then in that case, we're gonna have here the same an output folder that we're gonna store temporarily the information, and also we're gonna use none. None is gonna be we're gonna use the URL of the last run that we have. That means the one that I just running. And then when we run here, right? Okay, this again is gonna connect it with the EC2. It's gonna run the set up the environment for Python or the thing that we need, and then we're gonna be able to see the result at the end. So we're gonna come here to see what happened, right? So we can see here at the end that we were able to extract the UID right from the video. Here we had the UID, and also we were able to validate from our database. That's gonna be our Mongo database that UID was belong to us, and we have it stored inside our thing. And this is the total time it takes to do this process in this case, right? So we also have here, like for example, let's see all the information that we have stored in the database that we can do it from here. And then for example, we can run the Mongo display, and this is gonna connect with our Mongo cluster, and it's gonna download, I'm gonna print to the console all the information that we have inside here. We can see that we have, for example, the UID that we're creating to watermark the signal, and also we're gonna have a timestamp, right? It's gonna be an ISO date timestamp with the information about when it was that signal was watermarked, and also we're gonna have the link of the dash manifest that we use to watermark the signal. So we have all this information here. So, and this is the way. Well, now let's try the other scenario. Let's try to see if we use a URL from a signal that doesn't belong to us. So what we're gonna come here is we're gonna come to this is a Bitmoving, right? And we're gonna get a URL for a video of Bitmoving that you can see here, that video from Bitmoving. And what we're gonna do is we're gonna try to validate the URL. In this case, we're expecting that it's not able to validate because that signal doesn't belong to us. And that's what we're gonna do. We're gonna come back, and then we're gonna run our validation script, right? And then we're gonna play. Now we're gonna change the node for the new URL that we're using, right? For the manifest. And again, we're gonna connect. Yankee gonna connect with all the processes inside the cloud, and he's gonna try to validate here. So when we can see the result here, we can see inside the validation script, right? Mhm. That we connect, right, to MongoDB, to our database, but inside that signal that manifest when we extract the INI-MP4, that is the file that we are embedded physically the watermarking, we don't find any UID. That means we're not able to validate because that signal doesn't belong to us.